Assalamualaikum and greeting to all panels and other viewers. Welcome to our video presentation of Research and Development Formula Electric Vehicle from Politeknik Muadzam Shah. Before we begin our presentation, we would like to introduce our lecturer advisor. We would like also to introduce our group member. For your information, our team were divided by section, which are drivetrain and brake team. Nazarul, Irfan, Aidil, and Yusran. Bodywork team, Azharullah, Alif Aizat, Abisam Abasi. And fabrication task force, Alif Danish, Hakim, and Mohammed. Before I forget, I would like to introduce myself. My name is Alif as first presenter. I would like to give you an overview of FMEC and Electric Vehicle Formula Motorsport Education Competition is a tournament organized by UPSI, Technical and Vocational Department. These competitions are established not only to let students develop their vehicle for race, and they also need to present their development which we are doing here. For your information, we choose electrical vehicle for this competition because we want to learn new knowledge regarding EV. Furthermore, in our curriculum, it doesn't have subject that has theory and practical regarding EV.
Methodology flowchart. We refer to this methodology flowchart for our project process development. First, we begin with electric vehicle technology studies. They were then followed by comparing the existing Formula E design and system use. From here, we recognize that the main branch system to be studied is the lightweight body, braking system, and drivetrain. Thus, to ensure the correct design validity for each system, we had to undergo deeper studies to identify the related parameters to be evaluated by simulation and analysis. After the collected information is relevant, the process continues to fabrication and later testing for design confirmation based on the parameter constructed previously. Last but not least, the final stage is performance evaluation before finishing. From now on, we are ready to race. Here are the costing and details item and their summary accordingly.
Let's move on to our session breakdown structure. As you can see here, we divided structure on several sections, which are for bodywork, braking system, and powertrain system, and multimedia video editing. So that, turning our attention to our work breakdown structure, it also divided by several sections, which are lightweight, body system, energy source, and drive system. We divide the section due to effectiveness and time constraint. Turning our attention to concept design development, as you can see here, our progress from concept sketch until final design. We decided to choose all elements in our design because it have their own specialty on its own wing and feather. The concept design are focused on part in vehicle, which is on head, nose, and side pod. Here are our sketches development from first stage to final stage. Start from element, then follow by element detail, thumbnail, and lastly final design. Let's move to the scope of design frame study. During collision, bumper beams plastically deflection crash box plastically deform and fully absorb the kinetic energy. Longitudinal beam will absorb excessive impact and put occupant in risk. So that is why our frame have diagonal design frame and also our crash box. It is crucial because if accident happen, it will absorb the kinetic impact and more importantly, it make less risk to the driver. We use ANSYS software to identify the explicit dynamic toward our design frame. In ANSYS, the data for selected material show that 0.5 mm per second to avoid maximum crash box complete crumple. We do design simulation, simulate in full non-linear transient dynamic finite element analysis using ANSYS. The data shows that the material selection crumple will different stage. The most safe material that we simulate is zinc. The chassis we use are mild steel and also frame design. Lastly, we also did torsion test and cornering test using ANSYS simulation that shows stability frame design on the body frame.
Next, I will present the braking system. These are comparison between regenerative braking, drum brake, disc brake, and ABS. So, we decided to change brake system from automatic brake system to motorcycle brake system without changing the brake force. The weight reduction that we get almost 8 kg by using the brake rotor and caliper of the motorcycle. This weight reduction is crucial and slightly give us advantages toward our vehicle and more importantly, give us the same brake force. Let's move to design of the spacer for our vehicle. As we mentioned earlier, our electric vehicle car needs to have weight reduction. So we decided to change from the automotive hub into the customized wheel spacer without changing the purpose and properties. This upgrade will give us almost 2.2 kg weight reduction and still give same purpose and properties from the automotive hub.
Drivetrain system. Here we were divided by two categories part, which are drivetrain and power source. As you can see here, the difference of CVT and direct drivetrain. Based on our finding, we decided to choose CVT as our drivetrain due to smooth ride and maintain the output, especially during acceleration. Let's move to design selection. The design tree, which also have CVT, lithium battery and motor. The different with design 2 is the location of CVT and electric motor. As you can see, here position of electric motor in the middle of chassis and straight to the differential. It will create better center gravity. So finally, we decide to use design 3 as our final design to apply into our electric vehicle. These are how the design 3 in 3D modeling by using software CATIA version 5. These are how the CVT and electric motor connected to the differential shaft. These are the CVT that we developed and applied into our electric vehicle. Let's move to the next slide, which is the battery system cell. Due to weight reduction, we changed from the lead acid battery into lithium ion battery. So we need to customize the battery cell so that battery will give enough power into our electric vehicle. The data show that the weight reduction improvement that we apply into our EV. The total weight that we estimate totally is about 284 to 30 kg, not less or more. It will give us good advantage and also it will help our battery life usage become longer. Turning our attention now to fabrication process. As you can see here, how we fabricate the battery cell and also testing two motors.
Turning our attention now to our logo, themes and design inspiration. As you can see here, we use an old as element as design for our theme. There are several designs that we produce and these are the final design. As for conclusion, this is our first time participating in this competition using EV. There was a lot of knowledge that we learned from this project. That's all for now. I hope you guys enjoy our presentation. We really appreciate it. Thanks and Assalamualaikum.